Right, just this word quietly, because that's how traditionally we've got things to settle. Settling ponds, for example, we put fluid in and over time it settles. Yours are pushing out, what, 5,000 litres? Whatever's coming in is going out the other side.
Correct.
So it is the speed and the volume and the energy of that water that 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 is the question I've got. That's a bit. My mind is boggling at this volume of water because I've been in a lot of white water myself, and trying to understand how you're using that mechanics to actually separate down to that finer particle remove. Because when I want to put up a chart so people can understand my brain's confusion, and maybe that's why I'm trying to get it out of you. And I put up a chart of how fine a particle matters that you can separate out to, and how much you take out while this thing's flowing at let's call it full bore. And
Yes.
and that's the bit that's the black magic to me. And I just want you to sort of, if you can take the layman in me through this process of how you get it out to that level while the thing's
Okay.
still pumping. It's not a settling pond.
Rather than trying to get into complicated affinity hydraulics, let me answer it a different way. Included in our technical manual, we actually disclose the work that was done by Sydney University. So what I had to do was to take it to a totally independent authority, and that was the civil school at Sydney Uni, which is absolutely preeminent, unquestionable. And over a period of about 6 or 8 months, a student, together with supervision, studied the process, and we gave them access to a scaled down model where they could push it to its limits. And what they confirmed, they applied some theory that had been around for some time. It's pore theory and all sorts of things. And inside that report, they demonstrated that if we've got an aperture, and say that the aperture we're looking at is 500 microns, what we are doing is reliably removing something which is down to 20% of that aperture size. And that is because the aperture is side on, parallel to the flow, which means the water is flowing past that aperture, not through it. Hence the reason why you're challenging or questioning that process, because you are right. If we run 5,000 litres a second through a screen and push it straight through, the logic is that it will clog instantly, pretty much instantly. But what we're doing is running the water past the screen. And what that is doing is allowing the water to slip through and causing the particles to then lose that contact with the water, and then they actually don't settle. It's probably the wrong term. It falls under gravity. It just happens to be a bit slower because it's falling through water than falling through air.